In this video, I'm going to look at the general form of the sine function, which I have right here. Y equals to a sine, and then parentheses b x plus c plus d. Okay. The a value is going to determine the amplitude. Okay, so I have this set to degrees. If we use radians, then here at the origin, this would be 0 radians, and it would go up to 2 pi. This is the basic period of the sine function. Starts at 0, goes up. So this high value from the x-axis is 1, and the low value here is -1. The difference between those two values, 1 minus the -1, is 2. You divide that by 2, and that gives you the amplitude. Okay. So the middle line here, which is the x-axis here, is the midpoint. So it goes 1 up and 1 down. So that's how we say the amplitude is 1. You can think of it that way, or just think of the difference between the high value and the low value divided by 2 is the amplitude. So again, this is set to degrees. So if I click on this curve, you can see the way I defined it. So I defined it a sine bx, and I put 30 here just to make it more convenient when I graph it. Okay. And I'm going to change the values of the parameters, which in this case are a, b, and c, or a, b, c, and d. So you can see what effect that has on the graph. So first let's look at the amplitude, which is a, so over here, using this line right here, I can move the a to, say, 2. And you can see what happened to the graph. Okay. So instead of an amplitude of 1, it went to 2. So it goes up 1, -1. Notice the period stayed the same. You have 0 degrees, and then the midpoint here between this period is 180 degrees, or if we're looking at this in terms of radians, it's 0, pi, and 2 pi. Okay. Let's go one more to 3. So as I slide this, it changes this. I can click on it here. Okay, so you can see now if I set a to be 3, this parameter here, everything stays the same except the amplitude changes. Okay. Now let me put this back to 1. Okay. Click on this. Okay, so now we're back the way we were. Now, right now, the way this is written, A is set to 1, as you can see. B is set to 1. C is set to 0. And of course, D is set to 0. So again, the amplitude is absolute A. And the period is 2 pi over B, or in our case, since we're dealing with degrees, it'll be 360 divided by B. Okay? Dealing with radians, it'll be 2 pi over b. And again, here, the b will be positive. Okay? So if it's the negative, just ignore the negative or take the absolute value. The b here should be positive. And then the phase shift is going to be negative c over b. And then the vertical shift, that is how far the graph moves up or down. And this is all in relation to the original graph, which again is this right here. Okay? Where the main period goes from 0 to 360 in degrees, or 0 to 2 pi in radians. Now, let's go ahead and change the value of b so you can see what happens. Coefficient of the x. So let's go to 2. Okay, so you can see it gives you the change as you go. Okay. So now, the amplitude obviously stayed the same because A is still 1. But you can see now the main period goes from 0, instead of the 360, it's from 0 degrees to 180. Okay. Let's go one more. To 4. Okay, so now notice again the period stayed the same. But notice the graph now, the main period here, right here, we're looking at this. This graph just repeats. In this case, the original one every 360 degrees. In this case now with the period change. So notice it goes from 0 to 90 instead of 0 to 360. And that's why we're saying here that the period is always going to be 2 pi, or if you're dealing with degrees, which is what we're doing here, 360 divided by whatever b is. In our case, it's 40, so that's going to give us 90. Okay, so now notice if I go to say 0.5, okay, the period stayed the same, but now notice, or the amplitude I should say stayed the same, but now notice the graph got wider. So now it starts at 0, and when I say starts at 0, we're talking about the main period. This just repeats every 360 or every 2 pi radians. So this goes all the way up to 720. So the period got multiplied by 2. Okay, so that's why we say then if you have a graph, you want to find the period, and it's not your basic period, or your basic graph rather, and you take the 2 pi or 360 if you're dealing with degrees and divide it by whatever b is. So if b is 0.5, that's 1/2. Okay, so that's 360. So that would be 360. That's degrees divided by 0.5, which is 1/2. Okay. So simplify that. That's 360 times 2, and you'll notice the period goes to 720. Okay. So again, we're looking at the general form of the sine function and the effect it has when you change some of the parameters. In this case, the a, b, c, and the d. Okay. Now let's look at the d value. If we change the d value to 1, see the graph is just rising. Okay. So now that's where it is. Just moved up one unit. Okay. So now see, instead of going up to 1, it goes up to 2. And then the minimum value in this case is at 0. But 2 minus 0 divided by 2 is still going to be 1. So the period or the amplitude didn't change. The value of d just moves it up. So if d is positive, the graph just goes up. If d is negative, the graph just moves down. And when I say the graph, I'm talking about the initial or the original graph of the sine function. Okay, let's put this back to 0. Okay, so put it back where it was. Okay, so again, just remind you that I went ahead, the way I defined this, just to make it more easier on the graph here, is I have the c is multiplied by 30, okay, and this quantity is in degrees. So that's why then, if I change this, let c equal to 1. Okay, c is equal to 1. and I want to leave b at 1. Okay, so we want c to be 1, b1, a1, and d is 0. Okay, so again, basically, just so that you see what we have here is this, then it's going to become y is equal to a is 1, so this is going to give us sine of, okay, b is 1, so this will be 1x, or just x, plus c. And remember, in the way I defined it, this c has a 30 there in front of it, so this will be plus 30. And that's in degrees. And then d is 0, so this is what we have. Okay, so now, this is the graph we get if I make that change in the parameters. So now notice the graph, again, here's the main period in relation to the original one. It goes up like this, and it comes down. And then it ends, so one period ends at 330. So where did it start? At negative 30. Okay, so 330 minus a negative 30 in degrees gets 360. So the period is still going to be the same, but the graph shifted. Okay, normally it starts at 0 or the origin, shifted to the left. Okay, so that's why here then what we can do then, if you want to find out what the shift is, take whatever you have in the parentheses and solve it for b, or for x, I'm sorry. Bring that over, that's minus c divided by b. So we get this. Okay. So then you're going to take your original graph and just shift it either to the right or to the left. Okay, so now just look at this. Forget about this negative right here. Look at the whole thing. If this quantity right here is negative, then the graph is going to shift to the left, from the origin to the left. If this turns out to be a positive number, then it's going to shift to the right. So in that case, the graph would start right here. So if this had come out to a, in our case, it comes out to a, right here. If you set this equal to 0, this comes out to a negative 30. And that's in degrees. So the shift is 30 degrees to the left. If this had been a minus right here, this had been x minus 30, then this would come out to x equal to 30 in degrees. So the graph would have started right here to the right at positive 30 degrees, and then would go this way. Okay, and wind up at 390. The difference would still be 360. Okay, so again, changing the a value here affects the amplitude. Changing the b value from other than 1, it changes the period. And then, of course, if you have a constant right here, a c value, that's going to affect the shift. The original graph will either shift to the left or shift to the right, depending on whether this quantity here, when you solve it for x, is negative or positive. Okay. So again, we saw what the d value does. It just moves the graph up or down. So again, this is just a short look at the general form of the sine function. You could have a similar thing with cosine. And I do have other videos on my other channel, my Tony Pineda channel, on trigonometric functions. So this is just a short look here. I will continue with more videos on Cronus True Image 2018. And follow up with miscellaneous videos dealing with plumbing, sprinkler systems, and so forth. So thanks for watching, and we'll see you in the next video.